This video covers additional script tool parameter properties, including setting default values, drawing input features, and using filters to restrict input. It will also cover how to edit the tool help. In the previous lesson, we discussed the three types: required, optional, and derived, direction, input or output, and multi-value, yes or no. Next, we'll move on to the default or schema property. This says either default or schema depending on the data type that you've picked up here. It'll either say default or schema, and I'll show you an example of schema in a minute, but default is more common. If I've clicked on feature set, then there's a possibility of filling in the schema down here. Before discussing the schema parameter property, let's review relative paths. The reason we need to do this is because the schema parameter property will point to a dataset that will determine the schema for this feature set. So if we point to a polygon shapefile, for example, the feature set will be made up of polygons. We'll go into more examples in a minute, but let's focus on relative paths because you need to use a relative path to the schema that you set in order to preserve the portability. Many of the input values that you want to collect will be data paths. The default values for those need to be kept relative to the script tool so that when you move the script tool and you have sample data that goes with it, the default path will still work correctly. To help users understand how to use your tool, it's a good idea to supply sample data so that they can run the tool with data that you've tested it on already. Relative paths give you that power of making your tools and your maps portable so that when you give them to somebody else, they don't need to have your username in their path on their computer to get it to work. A relative path means it's a relative direction. You can think of my position as where I am could be a GPS coordinates, and that's relative to that coordinate system. Or you could describe my position as standing in front of the room, a relative position to where you're seated. So if we knew where you're seated and you said, she's standing 10 feet in front of me, then we know where I am. And if we move the whole room to a different position, I'd have different coordinates, but you could still, relative to Payam's position, you could still locate me. If you know where he is, you know where I am, because you know my relative position. So the same thing with file paths. It's a relative position, allows you to say, okay, it's in the same directory, or it's in a subdirectory of my directory, or it's up a few steps and over some directories. If you want to set a relative path for a file that's in the same directory as a file that's saying the path, then you can just use the file name. In this example, we're going back to this example I used for the os.walk, which was a directory of travel pictures. And there's subdirectories with pictures in them and also subdirectories in them. Those further have divisions down inside of them. If we locate backseat.jpg and we want to give a relative path to other files from backseat.jpg, say we want to give the relative path to the picture of the bridge. Well, since it's in the same directory, the relative path to the bridge would just be bridge.jpg. It's just the name of the file because it's in the same directory. You don't have to tell it to walk up or down or go around. But if we want to refer to this picture, say, canal JPEG, relative position of canal from backseat, we would have to say, okay, well, backseat's here. It's in Pix, Italy. Underneath that Italy directory is Venice, which is where canal is located. So that's why we would say Venice/canal JPEG to refer to the relative path of canal. If we wanted to refer to Istanbul, the relative position of Istanbul JPEG from backseat, we would have to use the dots, the two dot notation. 2 dots allows you to go up one level, because backseat is in the Italy directory, which is a subdirectory of PIX, which is where Istanbul resides. Dot dot will walk you up one level from where backseat is, and it'll get you into the PIX directory, and then you can refer to Istanbul. So what's the relative path of gate JPEG from backseat? Yep. Dot dot slash to get to know that Jerusalem is a directory. Jerusalem slash gate. What about fruit market? Yeah, you don't even need the dot slash at the beginning. It'll assume it's current Venice slash fruit market. With these examples, you can put together what you need to do for your project, because when you give paths in there, you can give relative paths. It'll update the full path appropriately to wherever you move the project. So if you give default values that are relative paths, it will fill in the full path for you when you pop up the GUI, but it'll be the right full path if you move your project to a different location. When default values are specified, relative paths should be used whenever possible when you're talking about paths, obviously. Paths should be specified relative to the position. In our example on the last slide, we're always specifying relative to the position of the backseat JPEG. In the case of script tools, you're going to specify the position relative to the position of the toolbox itself. Because remember, the script tool resides in a TBX file. If you have a toolbox that's in C, projects, code, cool toolboxes.tbx, and you have a raster that's C, projects, data, trees.tiff, how could you specify the relative path of the TIFF from the toolbox? Yes, dot dot slash data slash trees dot tiff. How about this example? This is a longer distance away. If you have toolbox in B, GIS, pies, sample scripts, ch23, so this is one of our example toolbox. If you have a shape file that's in the GIS Pi data chapter 23 small dir, the trails, I'm assuming. So you take it up to, go up to where they have a common thing, right? So you have to dot dot slash a couple of times. Does anybody have it? From the toolbox. Go ahead.
Do you have to put a slash between each double dot?
Yes, you do.
So we dot dot slash data slash everything.
Yes. Okay. So dot dot slash takes you up to the GIS Pi directory. It's like you're walking up from here to here with the dot dot slash. That gets you up to GIS Pi, and then you add on what's the directories for the trails. So then it would be data, chapter 23, small dir, trails. Yes, sir?
Why for the first example is it not two dot dot slashes? Because in the first one, I guess the second example B, and then the second portion is supposed to just be for GIS Python, and then.
So you're talking about example one, the trees TIFF one, or? Yeah. Okay. So so how many directories do you have to walk up until you're in a common directory for this one?
One.
Yeah. So you're just walking up until the thing is the same, until the path is the same, and then you walk down into wherever the other thing's path is. Okay, so for this one, that was a good question. For this one, you had to walk up 1, and for this one, you had to walk up 2, because it's 2 levels up to get to gist pi, which is the common path. B gist pi is the common path for these two, right? So if they were completely in different branches, you'd have to walk all the way up to the hard drive, wherever the hard drive is.
The
Cool.
thing that I'm not clear on is when you the full path name, like, is that one thing in your script that you specify the full path name, and then everything else you specify?
So the question really was like, well, where do you specify the full path? Where do you specify the perspective that I'm looking from, right? Well, you specify that by wherever you put your toolbox. Okay, wherever your toolbox resides, that's the assumed viewpoint for the full path. That you know, wherever you put your toolbox in a directory, if you say new toolbox under ctemp, then it's in ctemp. And then if you move it to the projects directory where you're going to submit this stuff, it's going to have that as the absolute path. But because you've specified relative paths for the data, it's going to update the full path for those to be the full path that wherever the toolbox resides.
Okay.
You'll do an example in a little bit, yes.
Why don't you use OS, like get current directory, and then use, like, if you have the OS current directory, you don't need like something like relative path. You always get current directory.
So the question was why, so we learned how to do the OS to sys.argv0 and to get the relative path, or the path of the script, and do relative things from there. Now what we're talking about is specifying relative paths in the script tool parameters default box. So if you look at this thing, this is where you're going to be specifying. There's a default path, or for things that you're doing paths for, you're going to be specifying a default value here. Okay, so this is a hard-coded relative path. Right, it's in the initial setup of your project. So this is so that when you pop up the GUI window, when the person that runs your script pops up that window, it'll populate it with a full path, but it'll be based on the relative path that you created, that you hard-coded in there. So you've got your data somewhere relative to your toolbox, and that's what you're specifying, your default data set. And then, of course, the user can use the default, or they can browse to their own, another choice. So you'll find that you do this, when you set it up, you'll, in that little box, the next to default, you'll set it up with a relative path. We'll have dots in it, or whatever you have. Then when you open it up again, it's going to show a full path there. But if you move that thing, it should show a different full path. You'll want to set defaults for all of your parameters for this. You're providing us with an example of how you can run it and that you've tested it with. That box will change where it says default below here in the box. If you've set something that uses a default, shows a default right below multi-value. But if you've set something like a feature set as your data type, then it'll show the word schema here. It'll just automatically update. If you want the user to be able to input polygons or points or lines, like to be able to draw on the map and take that as input to your tool, you can do that with a feature set. The schema allows you to set up a default symbology and set of choices. So use feature set and don't set a schema for it, then you won't be able to make a selection in here. It sets up the geometry type. So what I did to create the schema for this was I took a data set that was polygon and saved it as a layer, and it creates a LYR file. They call it a layer file, which stores the current symbology schema. So apparently I had set up the symbology. Cover 63P has these land cover types. It has 4 land cover types in it, or 3 or 4. In this case, it had 4. And I had used this sort of pinkish color for orchard. It keeps that information in the layer file. And I think you have to keep the original shapefile around for the layer file to work correctly, because it's got to talk to the data that's in the shapefile or feature class. Then what you'll be able to do, the user will be able to say, I'm going to draw a new polygon for woods. They'll select that and then draw a polygon on there, and that'll be given the cover type of woods automatically. So that's what we're doing on this slide. So you can click on the feature icon, one of these guys down here, and then click on the map. Click, 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 and you double click to get to put the final vertex in. It'll create a polygon for you. And this is another way to use feature sets. You can select features from a map layer, and so from an existing layer, and that will associate that type with it that you've selected. The fourth one down, the default or schema. For some things, it may be desirable to use an environment setting, whatever the environment setting is, for default value, and that's what this allows you to do. Say you want to use whatever the current workspace is as the default value for your input directory. This will dynamically do that. For whatever your current workspace is set up to be, it'll adapt to be that will be your default value. So if you select workspace down here. So the first box is for hard coding default values. The environment box is for using whatever the current environment setup is for default values. Filters are another useful thing that you can do. If you want to allow the user to select from a range of values or a set of values, then you can use filters. So you give them a set of suggested values. And there's all these different kinds of filters. So values for string, you can use them for other as well, but usually use the value list for that. A range, so that's for numerical values. For feature classes, you can select the types that you want. So if you only want them to be able to pick points or multi-point type feature classes, then you can restrict that with a filter. Or for file, this is a bit like in TK file dialog, we were able to list a set of file types that we would accept. This is the same kind of thing. You put in suffixes, endings that you would be willing to accept. And then again for field, you're allowed to select the type, the field data type that you'll accept. And same thing for workspace. You can filter the type of workspace you're allowing the user to pick. When you select a data type, the filter type is automatically updated. So obviously, if you select a data type of raster data set, the feature class filter is not going to be available for you. In this example, I've selected a string data type, and that allows you to turn on a value list filter if you want such a thing. So if you click on that, you'll get a GUI that you can fill in and specify the values that you want to be available. So that generates this, basically a combo box that will allow the user to pick from the choices that you've given up there. So if you want to use the Eat Spam and Eggs tool.
Is that passed into your module as a string?
Yes. So that comes in as a string, and then you have to do with it what you will. So you can imagine that behind there you would have conditional statements that would say, if the analysis type equals buffer, do this, and so forth. you notice that this is called a combo box, combination box. It drops down, and that's because we have multi-value as no. So the person will only be able to choose one of those. If we had multi-value as yes, it would look like a list box, and then you could choose more than one if you so desired. If you do the range filter, you get this cool slidey thing, and then you can put max and min in there. Of course, that's for numerical type values. You can also provide tool help, just like the ArcGIS built-in tools have, and you can provide help for each of the parameters, and you can provide general help for the tool. You go to the script tool, and then you go to the item description and click edit, and then you get the stuff over there. I'd say it's cool to do. I encourage you to polish your code before you do this, though. If the data type is a feature class, then you can use that feature class filter, and that allows you to restrict the geometry. Now we have an in-class exercise to practice using filters. You'll see the instructions over on the web page in more detail, but the basic idea is, first of all, write a script that prints the index and value of the arguments that it receives, both with get messages and print, and create a script tool that points to that script and has 3 parameters which use filters to allow the user to do 3 things. Choose the word float or integer from a combo box. Choose a value between -10 and 10 with a slider bar. Choose one or more polygon feature classes. That means you're using that filter on the feature classes. And then the printed output should look like what you have on this slide. Pause the video now and try it out. The scripts for this exercise should look something like what's shown here. There could be a function that both calls the print command and calls arcpy.addMessage, and you want to do this for every argument. So on line 10 there's a loop there that loops through each and every one of the arguments passed in by the users. So it doesn't need to know ahead of time how many arguments, because it's using a loop through the list, which is sys.argv. And it uses enumerate, so you can have both the index printed out and the argument when you call this command. Which this command on line 11 is creating the string inside of the parentheses. It's creating a string, and it's passing in that string that it creates into print arc. Then you see pictured on the right the properties that you should have. 3 properties. One, string. The first one should be a string type that allows you to pick 1 or 2 words. The second one should be a double type, so double is like integer. You can make a range between -10 and 10. And the third one is a feature class type, and then you can make the filter be limited to polygon files, and you can choose more than one at a time because multi-value is set to yes. This video covered the topics shown here, including default value approaches. You can do hard-coded, relative path, or based on environment settings. Usually, especially for the course, we want to use relative paths so that when we share the elements of our project, we can know that it's going to work in another location. We talked about the schema with the feature set or record set data type, which allows you to let the user draw points, lines, or polygons on the map as input based on a .lyr file. The filters include value, range, feature class, field, file, and workspace, and did an exercise with those. And then to edit the tool help, the steps are there. The next thing that is left in the script tool parameters is the obtained from property and the symbology property.